Hi, this is Engineer Ahmed speaking today on the topic electric actuators. Electric actuators are for the on-off application of valves like ball valves or butterfly valves. We will use a electric actuator, full open and full close condition. So as we discussed earlier, this is mainly meant for open or close for isolation purposes or bypass purposes. So this is also very useful in the process industries. So there are many industries, the international vendors are there, Rotark, Limitark, Auma, these are the main vendors of electric actuators. So here it is divided into three parts, this actuator. So this is a field connection, one side three chambers are there, one side field connection, center there is a motor and the other side we will have a control panel. So as I told you, electric actuator means it is motor operated basically. There is a motor which rotates depending on its design, maybe 600 rpm or 900 rpm or 300 rpm. So but how much rotation we require? Hardly 1/4 of a turn from close to open position, that is 90 degrees, that is equivalent to 1/4 of a turn. So but the motor is rotating more than 600 rpm or 900 rpm, many times more. So we have to reduce the rpm to 1/4 of a turn nearly. So for that we have to use a gearbox. Gearbox not only reduces the speed or rotations, but also it with the same ratio it increases the torque required. Torque means the force by the distance, rotating force, in fact you can call it rotating force, because this motor is a small motor, so it does not develop much torque to operate this big valve. So you need a large torque, so the torque is developed by gearbox. So this gearbox is also integral part of the actuator. So what gearbox will do? It reduces the RPM, at the same time it increases the required torque. So this spindle of the gearbox is coupled with the spindle of this ball valve, and it rotates nearly 90 degrees, that is 1/4 of a turn from close position to the open position. So if it is a ball valve, there is a bore inside, the ball like structure is there which is having a bore of the pipeline size. So when it is moves 90 degrees, this bore and the pipeline bore will matches and there is a full flow. So when it decreases 90 degrees, so it blocks the flow. It blocks the flow and fully closed position. So that is done by the actuator. So there is another chamber which consists of a control panel. So if you see this side, we will have a control panel. So control panel means you can operate locally as well as remotely. So it will have a LCD display, that is a liquid crystal display showing how much valve condition, valve position, all other things, as well as two switches. LOR means local off remote. Local off remote. If you are putting in local, remote is disabled, that is command from PLC it will not take. So when it is in local, you will have another switch, through that you can operate the valve. This switch is having three positions: open, stop, close. So when you open condition, valve will be start opening. So when you put in a closed position, it starts closing. So in center position you can stop the valve also. At that position, at any position you can stop. So this is a control panel. Through this you can operate locally. Once you are satisfied with the condition of the valve, So you can put it in remote so that it receives signal from the PLC and operates according to the PLC logic command. So that is a control panel. So another chamber we will have a field connection. Field connection means power connection. So you may be having a 3-phase connection. So this side you can open it and you can access the terminations. You can terminate the power cable and also the control cable. Control cable means the command from the PLC, open or close, that is discrete output. And also there are limit switch connections to show how much valve is open. There are torque switches. If high torque is operated, you will get the signal also. So all these things are in the control connections. So like this electric actuator will operate. So thank you.